Hello everyone, in this video we are going to learn how to solve trigonometric equations. When you attempt to solve trigonometric equations, you need to know that the solutions to sine theta equals to k and cosine theta equals to k only exist when k less than equal to 1 and greater than and equal to minus 1. And the solutions to tangent theta equals to k exist for all values of k. We usually use inverse trigonometric functions to find the angle. So what are the inverse trigonometric functions? That are arc cosine, arc sine, and arc tangent. There are also be like cosine minus 1, sine minus 1, and tangent minus 1. You need to be aware of that. It is different to cosine theta to the power of minus 1. They are completely different. Cosine theta to the power of minus 1, that equals to 1 over cosine theta. And sine theta to the power of minus 1, that equals to 1 over sine theta. It also does not equal to sine minus 1. And same, tangent minus 1, that is arc tangent, does not equal to tangent theta to the power of minus 1. And we use these functions to find the angle, and we call this angle principal value. And these principal values in the calculator have the following range. That is for the cosine minus 1, which is arc cosine, theta less than equal to 180 degrees, greater than equal to 0. For arc sine, that is theta less than equal to 90 degrees, greater than equal to minus 90 degrees. For arc tangent, that is theta less than equal to 90 degrees, greater than equals to minus 90 degrees. Now let's do some example question. Let's start from the simple question. So the first question, solve in the interval x less than and equal to 360 degrees and greater than equal to 0, 5 sine x equals to minus 2. So we write down that 5 sine x equals to minus 2. We have sine x equals to minus 2 over 5. This x equals to arc sine. minus 2 over 5. We can also write it as sine minus 1 minus 2 over 5. When you tap in the calculator, you will get minus 23.6 degrees to 3 significant figures. Since the interval of x is less than or equal to 360 and greater than or equal to 0, we need to find the value of x in that range. So you can use a cast diagram. Minus 23 minus 23.6 is the angle from the positive x-axis clockwise, so 23.6 degrees. And we know that the value of sine x is negative, which is minus 2 over 5. So x should be in the third and fourth quadrant. If x is in the third quadrant, so we have 238.6 over here in third quadrant. That is 180 degrees plus 23.6 degrees equals to 203.6 degrees to 3 significant figures. This is the first answer. And if x is in the fourth quadrant, that is 360 degrees minus 23.6 degrees equals to 336.4 degrees. Here it should be to 4 significant figures. So these two are the answers for the question 1. Now let us see the second question. It asks you to find the values of theta in the interval theta less than or equal to 360 degrees and greater than or equal to 0. That satisfy the equation sine theta equals to square root of 3 cosine theta. We can write down that sine theta equals to square root of 3 cosine theta. We can rearrange that. We have sine theta over cosine theta equals to square root of 3. We know that tangent theta equals to sine theta over cosine theta. So we can get tangent theta equals to square root of 3. Thus theta equals to arc tangent square root of 3, or you can write it as tangent minus 1 square root of 3. That equals to 60 degrees by using the calculator. Now we can check whether there are more values of theta that tangent theta equals to square root of 3. We can use a cast diagram. So CAST. We know that theta equals to 60 degrees. Tangent theta equals to square root of 3. And we found that the value of tangent theta equals to square root of 3 is positive. So we can have another angle theta in the third quadrant. So we have another angle theta that is 60 degrees. in the third quadrant. So we can write down that theta equals to 180 degrees plus 60 degrees. Here is not b, should be theta, so that is another 60 degrees. So 180 degrees plus 60 degrees equals to 240 degrees. So overall, we have two values of theta, that theta equals to 60 degrees or 240 degrees. Now let's see question 3. So for x less than equal to 360 degrees greater than equal to 0, the equation 4 times cosine squared x minus 3 sine squared x equals to 2 give your answer to 1 decimal places. So we have the equation 4 cosine squared x minus 3 sine squared x equals to 2. In here, we can use a trigonometry identity that cosine squared x plus sine squared x equals to 1. It also implies that sine squared x equals to 1 minus cosine squared x. Thus, we can use this one in the equation. We get 4 times cosine squared x minus 3 times 1 minus cosine squared x equals to 2. We rearrange that, we have 4 cosine squared x minus 3 plus 3 cosine squared x equals to 2. We have 7 cosine squared x equals to 5, and cosine squared x equals to 5 over 7. So we have cosine x equals to plus minus square root of 5 over 7. So I have two situations. The first one is that cosine x equals to square root of 5 over 7. And the second condition is that cosine x equals to minus square root of 5 over 7. Now, let us find the value of x in the first situation. We have x equals to arc cosine square root of 5 over 7. You will get 32.3 degree in the calculator, that is 1 decimal places. And then you use the cast diagram, so CAST. Since the value of cosine x greater than 0, which means x is in the first and fourth quadrant. So we have the value. The first one is 32.3 degrees, and another 32.3 degrees in the fourth quadrant. So we have 360 degrees minus 32.3 degrees equals to 327.7 degrees, 1 decimal places. In these situations, we have two values, that is x equals to 32.3 degrees or x equals to 327.7 degrees, 1 decimal places. Now, if cosine x equals to negative square root of 5 over 7, x equals to arc cosine minus square root of 5 over 7, that equals to 147.7 degree to 1 decimal places in the calculator. And now let us see in the cast diagram, CAST, we have x, that is 147.7 degrees. We know that the value of cosine x less than 0. So x is in the second and third quadrant. So there should be another angle in the third quadrant. We need to find the value of this theta. To be aware of that, the angle from the positive x-axis to this line from the clockwise, that is also 147.7. So we can get the value of the x, the blue one, should be 360 minus 147.7 degrees. That equals to 212.3 degree to 1 decimal places. In these situations, we have x equals to 147.7 degrees or equals to 212.3 degrees. So we have the 4 solutions of this question. The first one is 32.3 degrees, 327.7 degrees, 147.7 degrees, and 212.3 degrees. Let's move on to see some harder questions. So question 1, solve the equation cosine 3 theta equals to 0.766 in the interval theta less than or equal to 360 degrees and greater than or equal to 0. In the previous question, we solved the equation like cosine theta equals to k. The difference is in this question is that here is 3 theta. So for our convenience, we can change it. We can write down let alpha equals to sine theta. Then the equation becomes cosine alpha equals to 0.766. And then we also need to find the interval of the alpha. Since alpha equals to 3 theta, then the interval of alpha should be alpha less than or equal to 360 times 3 and greater than or equal to 0 times 3. So we times 3 to the interval of the theta to get the interval of alpha. So alpha less than or equal to 1080 degrees, greater than or equal to 0 degrees. Now we start to solve cosine alpha equals to 0.766. Use a calculator. You will do arc cosine 0.766. That should be equal to 40.0 degrees to 3 significant figures. Then we can use the case diagram to find other values. So here is a case diagram, CAST. We have 40 degrees over here. We know that cosine alpha is positive, which means alpha is in the first and the fourth quadrant. So we have another angle 40 degrees in the fourth quadrant. Thus, we can get a value that alpha equals to 40 degrees, and the second value should be 360 minus 40 degrees, that equals to 320 degrees. Well, we notice that alpha is less than equals to 1080 degrees, which means we need to do 3 complete revolution. We know that the positive x-axis should be 0 degrees, and we do the 1 revolution, we can have 360 degrees, and the second revolution we have 720 degrees, and the third revolution, that is 1080 degrees. So we can have other values, that is 360 plus 40 degrees. The angle looks like that. That equals to 400 degrees. Then we can also have 720 degrees minus 40 degrees. The angle looks like that. So let me redraw it. So the first revolution, the angle looks like that. That equals to 680 degrees. And then we can also have 720 degrees plus 40 degrees. Its angle look like that. So we've done the 2 revolutions and then add 40 degrees. We get 760 degrees. And also we have 1080 degrees minus 40 degrees. That equals to 1040 degrees. Is the angle that we complete 2 revolutions and nearly done the second and the third, nearly done the third revolution. Yeah, this is 60, 720 minus, and another revolution. Yeah, like that. This is the values of alpha, but we need to find the value of theta. So we have 3 theta that equals to 40 degrees, 320 degrees, 400 degrees, 680 degrees, 760 degrees and 1040 degrees. Thus, theta equals to 40 divided by 3. So we divided by 3. We have 13.3 degrees, 107 degrees, 133 degrees, 227 degrees, 253 degrees, and 347 degrees to 3 significant figures. Thus, we have done this question. So for this question, we use another letter to present 3 theta, and then we need to find the interval of the alpha. So we can find the value of the alpha at first, and then to find the value of theta. Now let's move on to see other questions. So for question 2, solve the equation sine bracket x plus 30 degrees equals to 0.5 in the interval x less than equal to 360 degrees greater than equal to 0. So similar, we can use another letter to present x plus 30. So let alpha equals to x plus 30 degrees. Then we can have sine alpha equals to 0.5. Secondly, we need to define the interval of alpha. The interval of alpha should be alpha less than equal to 360 plus 30 degrees greater than equal to 0 plus 30 degrees. So alpha less than equal to 390 degrees greater than equal to 30 degrees. Well, in addition to use a cast diagram, we can use a sine graph to find if there are other values. Firstly, let us write down that sine alpha equals to 0.5. So alpha equals to arc sine 0.5, that equals to 30 degrees. Now let us draw the sine graph. (90 degrees, 180 degrees, 360 degrees. That should be 270 degrees, 360 degrees, and 450 degrees. We draw that. I hope you can now draw the sine graph completely and successfully. The sine graph looks like that. We know that sine alpha equals to 0.5. So we have 0.5 over here. And if y equals to 0.5, cross this sine graph, we have 3 values. The first one we have got that is 30 degrees, and the second value and another value. Now let us first to find this value. That should be 180 degrees minus 30 degrees. wait, let me write down that alpha equals to 30 degrees, and the second one should be 180 minus 30 degrees. Since the distance from here to here should be 30 degrees. And similarly for the third one, the distance from here to here is also be 30 degrees. The third value should be 360 plus 30 degrees. So we get that alpha equals to 30 degrees, 150 degrees, and 390 degrees. We know that alpha equals to x plus 30 degrees, so we need to get the value of x, that we need to minus 30 degrees. We have x equals to 0 degrees, 150 minus 30 degrees, that is 112 degrees, 120 degrees, and 390 degrees minus 30 degrees, that should be 360 degrees. Thus, we got the answer of this question. Now let's move on to see the third question. So for theta in the interval x less than equal to 360 degrees, greater than equal to 0, the equation 2 sine squared theta minus sine theta minus 1 equals to 0. We can see that for this equation, this is a quadratic equation. You can see as 2x squared minus x minus 1 equals to 0, where x equals to sine theta. Now what we do is to solve quadratic equation. We can write down that 2 sine squared theta minus sine theta minus 1 equals to 0. And we can get 2 sine theta plus 1 times sine theta minus 1 equals to 0. We factorize the left-hand side. Since if you see 2x squared minus x minus 1 equals to 0, we can have 2x plus 1 times plus x minus 1 equals to 0. It is the same way to solve this quadratic equation. Then we have 2 sine theta plus 1 equals to 0, and sine theta minus 1 equals to 0. We have 2 sine theta equals to minus 1, so sine theta equals to minus half, and we have another possible value that should be sine theta equals to 1. Now let us first see if sine theta equals to minus half, then theta equals to arc sine minus half, that should equal to equals to minus 30 degrees if you use a calculator. And then let us use the cast diagram. Cast diagram. So CAST, we see that sine theta is negative. So theta should be in the third and fourth quadrant. So here is another 30 degrees, here is 130 degrees. For this situation, we have that theta equals to 180 degrees plus 30 degrees. That equals to 210 degrees. And another possible value, that is 360 degrees minus 30 degrees equals to 330 degrees. Those are the values of theta if sine theta equals to minus half. If sine theta equals to 1, we can find the solution using a sine graph. Because 1 is the maximum value of sine theta. Let us draw the sine graph quickly. So 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Since the interval of x, that should not be x, I written wrong over here. That should be theta. Sorry for that. The interval of theta is less than equal to 360, so we only draw up to the 360 degrees. Then we have 1 over here minus 1 over here. So we have the values and draw the graph like that. Just a sketch, not an accurate one. We can see that if sine theta equals to 1, we can have theta equals to 90 degrees on the graph over here. And in the interval at theta less than equal to 360 degrees, greater than 0 degrees, there is only one value. So we have that theta equals to 90 degrees, 210 degrees, and 330 degrees. We have 3 solutions for this question. Okay, let's move on to the final question. Find the values of x in the interval minus 180 degrees greater than equal to x less than equal to 180 degrees, satisfying the equation 2 sine squared x plus 9 cosine x equals to 3 cosine squared x. If we want to find the values of x, we can just leave sine x or cosine x. In here, I want to just leave cosine x. I don't want the sine x. So what we can do, we can use the trigonometry identity that sine squared x plus cosine squared equals to 1 implies that sine squared x equals to 1 minus cosine squared x. Thus, we have 2 sine squared plus 9 cosine x equals to 3 cosine squared x. Rearrange that, we have 2 times 1 minus cosine squared x plus 9 cosine x equals to 3 cosine squared x. Then we have 2 minus 2 cosine squared x plus 9 cosine x equals to 3 times cosine squared x. Thus, we can have that minus 5 cosine squared x plus 9 cosine x plus 2 equals to 0. Then we have 5 times cosine squared x minus 9 cosine x minus 2 equals to 0. And then what we do is to solve quadratic equation. We can see this equation we can factorize. Then we have 5 times cosine x plus 1 times cosine x minus 2 equals to 0. So we have two situations. The first one that 5 cosine x plus 1 equals to 0. So cosine x equals to minus 1 over 5. And this we have x equals to arc cosine minus 1 over 5. By using calculator, you will get 101.5 to 1 decimal places. And use a CAST diagram, CEST. We have 101.5 degrees over here. Since cosine x less than 0, so x is in second and third quadrant. So we have another angle, 101.5 degrees over here. Thus, the second possible solution of that should be 360 minus 101.5 degrees. That equals to 258.5 degrees to 1 decimal places. For this situation, we have x equals to 101.5 degrees and 258.5 degrees. Now let us see the second situation, that is cosine x minus 2 equals to 0. Cosine x equals to 2. But you need to remember that the maximum value of cosine x should be 1. And the minimum value of cosine x, that is negative 1. So for this situation, we don't have the solutions. Since cosine x less than equal to 1, greater than equal to minus 1, there is no solutions. There is no solution for cosine x equals to 2. So we only get the two possible solutions, that are x equals to 101.5 degrees and 258.5 degrees. That are the solutions for this question. But you can see the question said that interval of the x should be less than equal to 180 degrees, greater than equals to minus 180 degrees. So we need to change the value of this one in another form. That should be negative 101.5 degrees. Therefore, x equals to 101.5 degrees and negative 101.5 degrees to 1 decimal places. So here is the end of this question. And also here is the end of the video. Thank you for watching. Hope you enjoy it.